Nth term is just a formula that will allow us quickly work out any term in any given sequence. Generally, the formula will have a letter n in it, and the purpose of the letter n is to represent the position of each of the term in the sequence. We'll explain more as we go along. Saying 3 times table or multiples of 3, we will represent multiples of 3 as 3n, and we represent multiples of 5 as 5n. As I said before, n represent the position of each of the terms in the sequence. So in the multiples of 3, the first multiple of 3 is 3, because 3 times 1 gives you 3. If you want the second number, n becomes 2. 3 times 2 is 6, and that is the second multiple of 3. So the n is there to help us know the position of each of the terms in the sequence and to help calculate missing terms as well. We first start by checking the rule of the sequence. So we know it's add 2 every time. Now the rule tells you the kind of multiples that is hidden in the sequence. So the fact that this is add 2 every time, that means this sequence follows multiples of 2. So we start by doing multiples of 2. So that's our multiples of 2, and multiples of 2 represented as 2n. Now you could see that we can compare each of the term with the original term. You can choose any point to compare, but I always prefer to choose the very first terms. So comparing 2 to 3, our aim is to get to the original one. This is a hidden sequence, so we want to get to the original one. You can see from 2 to 3, we have to add 1. So we can now confidently say the blue sequence is simply 2n plus 1. We find the rule is plus 5, so which means the sequence has an aspect of multiples of 5 in it. So let's list multiples of 5. And multiples of 5 is simply 5n. We compare the first term. 5 we want to get to 2. 5 to 2, we need to take away 3. So therefore, the original sequence, the formula is 5n minus 3. Now let's look at the third one. That also plus 2. So it has an element of multiples of 2 in it. We list multiples of 2, which is 2n. We compare the first two terms. 2 to negative 5. If you are not sure, use number line to guide you. That is 2. You are counting all the way to negative 5. When you count, you realize that you are going down 7 steps, and going down is negative 7. So the formula now becomes 2n minus 7. We're going to use the same structure to work out the decreasing sequence. The difference here is that we have a negative rule. So we're going to list negative multiples. So negative multiples of 3 will give us negative 3, negative 6, negative 9, negative 12. And in short, it's represented as negative 3n. We compare negative 3 to 10. Again, if you're not sure, use number line. From negative 3 all the way to 10, you count, you realize that you are going up 13 steps. Therefore, the formula is negative 3n plus 13. Now E, negative 4 multiples, we list them. Negative 4 to negative 3. You add 1, so the formula is negative 4n plus 1. And lastly, our rule is negative 5. So negative 5 multiples, negative 5n. From negative 5 all the way to 6, you count. That means you go up 11 steps. That's positive 11. So the formula becomes negative 5n plus 11. So this is how we arrive or generate the nth term of linear sequence. Always find the rule, use the rule to generate the hidden sequence, then compare the very first term of the hidden sequence with the first term of the original sequence to know whether to add a number or take away a number to complete the sequence.